This video is going to cover multiplication and division of decimals. When you're multiplying, you could follow these 3 simple steps. Step 1. What show is that from, my friends? Alright, first step, multiplying decimals. Multiply the decimals as you would any whole numbers. The decimals do not need to line up like they do in addition and subtraction, so don't think that they do. Step 2, after multiplying, remember to place the decimal in the product, which is the answer to the multiplication problem. And then step 3, move the decimal to the left. How many places? It depends on the sum of the decimal places in the factors, which are the numbers that are being multiplied. So it's best if I just show you. Here are 4 samples. What I'm going to do is do 2 and then let you try 2. So for the first one, 6 times, remember parentheses mean multiplication, and we do that so that you don't think this. You would go, oh, that means 6 minus. It doesn't. So we use parentheses. So that means 6 times a negative 3.21. When you are setting these problems up, it makes sense for you to take the number with the most digits and put it on top. So I'm going to put the 3, 2, 1 on the top. Notice I didn't put the decimal in there and I didn't put the negative sign in there. You don't need that right now. And then I'm going to put the 6 down here. And I'm going to multiply. 6 times 1 is 6. 6 times, that's a bad 6. 6 times 2 is 12. Carry the 1. 3 times 6 is 18. Plus 1 is 19. Now what you do is you go up to the factors. There are 2 digits to the right of the decimal here. So we got to move the decimal over 2 places. So this is 19.26 or 19 and 26 hundredths. And then you look at the signs. I have a negative and I have a positive here. The signs are different, so the answer is negative. Look at the second problem. Negative 12 times a negative 10.03. Again, I'm going to put the number, the most digits on top, and I'm going to leave the decimals out now. I just think it makes things a little bit easier looking, a little easier to deal with. So the first thing I'm going to do now is multiply. 2 times 3 is 6. 2 times 0 is 0. 2 times 0 is 0. 2 times 1 is 2. Then you have to put this 0 down here. This is a placeholder. It's a placeholder because I'm taking the number that is in the tenths place and I'm multiplying it by the digits on top, so my answer needs to start in the tenths place. 1 times 3 is 3. 1 times 0 is 0. 1 times 0 is 0. 1 times 1 is 1. And then I add all this up. I get 6, 3, 0, 2, 1. Then I go back up to my problem and I say, all right, I have 2 digits to the right of the decimal. There's none over on this one, so I'm going to move the decimal over 2 places. The answer is 120.36. And then you look at the signs. I have a negative and a negative. Negative times a negative equals a positive. So the answer is 120.36. Now, pause the video and try the next 2 on your own. And then play it back. See if you got it correct. Okay! I'm putting a number with the most digits on top. 1002. Didn't even realize how close this is to the prior problem. And on the bottom, I'm going to put 136. And then I have 6 times 2 is 12. I'm just writing the 12 down here because if I carry the 1 up to the top, it just ends up down here. 6 times this next 0 is 0. 6 times 1 is 6. Put in a 0 because I'm going to tenths place. 3 times 2 is 6. Then I have 0, 0, 3. Then I'll put in 2 zeros because now I'm multiplying the number in the hundredths place. I mean, or the hundreds place, not hundredths. Sorry. The hundreds place, so I want my answer to start in the hundreds place. 1 times 2 is 2. 1 times 0 is 0. 1 times 0 is 0. 1 times 1 is 1. And I'll add all this up. And I get 2. And I get 7. And I get 2. And I get 6. And I get 3. And I get 1. Then what I'm going to do is I'm going to check the number of decimal places. I have 2 here. I have 2 here for a total of 4. So it needs to move over 4 places. 1, 2, 3, 4. So my answer is 13.6272. Both of these are negative, so my answer is going to be positive because a negative times a negative is a positive. All right, moving on along, my friends. This one here, it doesn't matter which one you put on top because they both have the same number of digits. I'll write it out like this. And I'm going to do 4 times 8 is 32. Again, I'm just writing the 3 because if I carried it up here, it would just end up down at the bottom anyway. 4 times 6 is 24. Put in my 0. Now, I don't need to put in 0 times all of these. It'll be a bunch of zeros. So I'm going to move to the hundredths place next with this 5. So that means I need 2 zeros here. 5 times 8 is 40. And then 5 times 6 is 30. I add these up, 2, 3, 4, 6, 0, 3. And then I count the digits to the right of the decimal. I got 2 here for a total of 4. Move it over 4 places. I have 30.6432. And then I have 1 that's negative. This one's negative. This one's positive. Signs are different. The answer is negative. Cool! Let's move on, shall we? Time for dividing. Okay. Boy, wouldn't it be nice if they were all this easy? This is just to kind of refresh your memory here. This here we call the dividend. This is the divisor. The answer is a quotient. Now, the big thing that you have to remember with the division problem is which number goes in the house. So, the first one is the one that goes in the house. So I think of it like this. You have 2 numbers that are running, right? They both want to get in the house. Who's going to get in first? The first one. This one. So when setting up the problem, 10 goes in the house. 5's on the outside. Don't forget that. Then you say, all right, well, how many times does 5 go into 10? 2 times. 2 times 5 is 10. Subtract 0. We're done. Great. All right, well, now I got a question for you. What if, you don't have to write this down. What if the decimal of the dividend and divisor moves same direction by the same number of places, or the same amount? What happens? So in other words, I have the same problem, 10 divided by 5. But now what I'm going to do is say, all right, I'm going to take this decimal here, which is there, move it to the right one. This one, move it to the right one. So the new problem would actually be 100 divided by 50, because I just moved both decimals to the right. When I divide 100 in the house divided by 50, it goes in 2 times. I get the exact same quotient. Why? You may be wondering, why do I get the same quotient? Because they are proportional. They are proportional because, now this is something else you don't have to write down. Just make sure you understand it. We moved the decimal, I should have put that in there, by the same amount of places. This is what we're going to use. This idea is what we're going to use to divide decimals. The idea that if you move the decimal the same number of places, that you end up with a proportional problem, and you're going to end up with the same quotient. All right? So let's move on to the next page. Here is the rule. All right. Do not divide by a decimal. That's the thing you have to remember. Instead, what you're going to move the decimal in the divisor, the number on the outside, to the right until it becomes a whole number. Then you're going to move the decimal of the dividend, the number in the house, by the same number of places. Divide as normal, and the decimal goes straight up, right into your answer. So, here, for example, I have 10 divided by 0.5. What I want to do, if I set this up, I would say, all right, 10 divided by 0.5. I don't want to divide by a decimal, so I'm going to move the decimal to the right, however many places I need to until this number on the outside is a whole number. Well, I only have to move it once. If I move that one once, I have to move this one once. And then what I have is 100 divided by 5. Now, proportionally, these are, or I should say these two things are proportional. So, 5 goes into 10 2 times. Subtract, bring the 0 down, it goes into there 0 times. So, 10 divided by 0.5 is equal to 20. Now, I know some of you are saying, what's up with this? I don't get that. What is going on? How in the world do you take a number 10, divide by something, and end up with something bigger? Students always have that question. So, this is what I have to say to you. Let me say if I had pie. I like pie. I had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 pies. And I said, all right, I'm going to take these 10 pies and I want to divide them by 5. What that means is you're going to count out 5 pies. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Ooh, perfect. How many sets of 5 do I get? I get 2 of them. All right, great. But let's say now instead of that, I want to divide by 0.5. Let me erase all this. So now what I have is, whoops, my 10 pies, and I want to divide by 0.5. What that means is that I want to only count over half of each one, or I want to split each one of these in half. That's what 0.5 is. And then how many halves would I have? I'd have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. That's how come. Anytime you divide by a decimal and you take a whole number and you divide by a decimal, the quotient's going to end up bigger than the dividend originally was. Kind of interesting stuff. Let's move on, shall we? Here's some samples. I'm going to do one to show you, and then you're going to try the other 2. Okay? So the first one, negative 46.2 divided by 12. Again, I am going to completely ignore the decimals. So the first number goes in the house, and 12 is on the outside. The number on the outside, the divisor, is already a whole number, so I don't need to do anything to it. What I'm going to do then is 12 goes into 46 3 times. 3 times 12 is 36. Subtract, it's 10. Then I'm going to bring down. Now, by the way, if you had a number here, this 10, if it was larger than your divisor, the number on the outside, that means that this number you picked up here is too small, okay? Just a little bit of advice. When you do your subtraction, this number down here should be smaller than your divisor. Bring the 2 down then. Now, 12 goes into 102. Oh, no, how many times? 8 times. 8 times 12 is 96. And we'll subtract 102 minus 96 is 6. We're not done here. We don't do remainders, okay? What we're going to do is we're going to add a 0 and bring that down. Now, 12 goes into 60. How many times? 5 times. 5 times 12 is 60. And now we're done. Then, the decimal, again, straight up goes like this, right up into your answer, right into the quotient. Now, you look at the signs. I have a negative and I have a positive. So my answer is going to be negative. Negative 3.85. All right, move on to the next 2. What I want you to do is try them yourself. And then, so pause the video and then play it and see if you get the answers correct. Go ahead and try it. All right, you got to set it up right. So 1.824. It's 1.824 on the inside. I didn't put the sign in there though. And on the outside, I have 0.12. The number on the outside, the divisor, I got to make a whole number, so I have to move this over 2 places. If I move that over 2 places, I move this over 2 places. And then what I have is 182.4 divided by 12. 12 goes into 18 one time. It's 12, subtract, I get 6, bring the 2 down. 12 goes into 62 5 times. 5 times 12 is 60. Subtract, I get 2. Bring the 4 down. 12 goes into 24. 2 times. 2 times 12 is 24. And I'm done. Decimal straight up, yo! Into your answer. You look at the problem, and I have a negative here, and I have a positive here. Signs are different. The answer is negative, so this is negative 15.2. Okay? All right, moving on to the last one. I have 4.20 divided by 3.5. The decimal has to move over once. So the new problem, we have to do it down below here, is 42. Oh, reminder, is 42 divided by 35. Okay? So 35 goes into 42 once. Oh, the decimal's right here, by the way. And 1 times 30 is 35. Subtract. I get 7. I have to add a 0, bring it down. 35 goes into 70. 2 times. 2 times 35 is 70. And we're done. Decimal straight up into the answer. And here I have 2 negatives, so my answer is positive 1.2. Okay? That's all, my friends. I know it's kind of a lot, but watch it again if you need to. I don't think it's that bad of a thing. Goodbye.